สวัสดีครับ distinguished professor and research fellows today. Good morning, everyone. And I'm from Thammasat University. Of course, it's about 50 kilometers from the downtown Bangkok to the northern part. And I also work in the Ministry of Natural Resource and Environment. Today, I will talk in terms of not about the scientific evidence, but what I'm going to focus is about the pilot scale that Professor Yang have been described a little on that. Next. Yes, before having this talk, I would like to express my sincere gratitude to the organizing committee for inviting me to this talk. And our work will focus only on the uncontrolled battery, which not have put in the big box and going to the control one, just like the EV battery. What we are going to do is about electronic appliance battery only. So that would be include the drone, the power bank, and any motorcycle battery. Okay, next. Of course, this is the slideshow about our motivation, talking about precious metal inside the lithium-ion battery. The price is quite high, and also, as you know, that we don't have natural resources in our country, and all energy security depend on the input material. So what we have to do is to do something to recirculate of that one. Of course, using the lithium battery will be show you in the bright side for the green society. However, one that should be concerned is about the dark side. Next. The dark side in this, the picture showing here, of course, when you have a mining to take away or extract all those metals, you can see how different and environment have been jeopardized on that. Of course, this is not only to the environment, but also to the community. Many heavy metal have been released and over the tolerance limit, and also some water cannot be used in the nearby this mining. Next. Again, not only about the rare earth, but also the graphite thing. And you can see how the mining activity and environment have been jeopardized on that. Okay. Next. One thing that we have to concern is about the people who working in the mining has been abused. So you can see the price from the EXW price comparing to what you have seen before in the slide, quite different. So this must be the one that we should concern on the recycle and circular economy business. Next. Well, I would like to thank to EGAT. This is a state enterprise who generate a lot of electricity and distribute to the country. And they are concerned about this for about 6 years ago, that we have 3 projects consecutively, starting from EV1, talking about the laboratory scale to do to find out the conditions that we can use for the second part and the first part of recycling and the second part of the recycling. Of course, the first one, the one that we have the commit is about 400 kilogram or to 1,000 kilogram a day of crushing and getting the black mass. After that, we use black mass to do some hydromet process to get the final product of lithium about 400 gram a batch, or totally commitment going to be 1 kilogram for the total. Next. So the project, our project has been, EV2 has been working. I mean, the plant has started about 2 years ago in 2023, I think, at the end of 2023. And then we construct this plant in about 1 EGAT plant, pilot power plant, which is about 40 kilometers from my university. And we have this kind of products. You can see the separation from the fine particles to the one that can separate from like a aluminum foil. Okay, next. So this is our okay. Very short one that we ไปตรงกลางๆได้ไหมครับไม่ได้เนาะ So the whole plants, including two crushing and grinding process, along with the sieving to separate the size, and also we have 3 sets of the dust control pollution, which include the cyclone and the backhouse filter on the back side. Next. So let's see in detail in 3D model. This is one of the crushing unit, and the other one is right here. And we have 1 through 3 of the backhouse filter, and together with the 3 cyclones. And these are the screening one. So in this process, there are about 14 point of sample, and we take all samples, 14 points, and then we characterize by XRD, XRF, and ICP-OS to classify how product and quality is. Next. Again, the agency would like to know how much we can produce of the black mass. So we did mass balance on that, and about 50% of the black mass can be generated. 50 to 60% of the black mass can be generated. Other than that, we have to, we cannot, if you look at this mass balance, we can see that the lead appear in this waste. So we have to concern not to put this directly to the retail disposal. Next. Looking at these might be more clear. As you can see here, about 100 of the lithium battery, we can get about the black mass around 60%. And other, we can do some recycle on that, including copper, ABS, iron, and plastic, and also aluminum. Next. We also did life cycle assessment in the environmental impact, comparing to the incineration system has been existed in one factory to the east of Bangkok. So they use the furnace to burn it, and then we compare between the burning and the crushing process. Next. And the impact on that, and you can see very clear that by the crushing process have environmental impact much less comparing to the incineration process. Next. For whole category, of course, global warming as well. We not only work on the construction, but we also do the preparation of the battery before going to the process by safety concern and also health risk, and do the public hearing as well. Next. I moved from the first crushing process to the second one, which we firm that this is the first crushing process in Thailand. We are going to have the second one as the second part to extract the metals. Next. So we start the work in 20 liter size reactor capacity, and students enjoy working that. However, not very fun. So next. So what we get is all the graphite, which I couldn't put, I'm sorry, I didn't put the graphite. We got about very good fingerprint with the graphite RJCD, XRD library reference. And also what we have is a lot of nickel, copper, cobalt compound that is quite very difficult to separate, and also manganese oxide, and the final product is lithium carbonate. The agency would, of course, be to extend the work to the pilot scale. We did the mass balance by 2 kilograms, and what we can get lithium carbonate is about 165 grams, and also we get some not wastewater, but somehow that we can do more to precipitate the lithium more on that. The utility that we use for the 6 runs is about 5 units of electricity for each run. Next. So we did the cost estimation, only the profit margin of black mass, and also the product that we get is about 3 times comparing to if we sell directly from black mass to the market. Next. We go further for the 100 liter of size reactor capacity. We pretty much getting the same result as before. Sure. Next. So this is our work on 10 kilogram of back mass, and then we did demonstrate. We show the product on the side with the graphite about 5. Of course, some loss somehow, and we get lithium, copper nickel compound about 12 kilogram, and manganese as well, and some concentrated lithium solution for 3 liter, which can be used directly to the recycling. And utility that we use for this 100 liter of capacity is not very much, only 27 kilowatt hour, and all wastewater that we generate is about 2.4 cubic meter. So we are firm to open the learning center, and if you got the chance, you can visit us as well. Next. So we can find a research gap if somebody would like to go further on that. Next. Of course, on this life cycle, we can to get the material into the process precisely, we need a sorting machine. Now we are going to have the 3rd version of the sorting machine using the image recognition and also discharge unit that we prefer to for the safety on the automatic unit. Next. We also talk to because Thailand start to have this kind of lithium battery more and more, and so we think that if we can talk with the Department of Industrial Work and put that in the waste code, that must be very good. So we success on that. Next. So the ongoing project on my research team is talk about the graphite, high concentration graphite to purify that and refabricate that. We got help from Chulalongkorn University to do the work on that. I don't have that kind of information or knowledge. And also we also working with solar panel recycling that we can separate the black sheet 100% of that without using only small energy use. And also CO2 utilization with the kinetics on the lithium recovery. And we also talking about to purify the nickel copper on that size, because the one that we get is very hard to separate. Of course, last but not least, I would like to appreciate all the team from different universities, professors, students, and help me to get this 2 project done. Thank you very much.
Thank you, Professor Nurak. Okay, so the forum is now open for questions. If there is any question, please raise your hand. We got some time. I saw Ajahn Chitti pointing something. Actually, I have some question for Professor Nurak. So when you separate manganese from copper and nickel, what are the process that you do? Like I remember.
Thank you. Actually, what I feel in the technology of the precipitation is not new, not relative new. So chemistry 101 would be applied. So, and this is the kind that we can, go further for the industrial. We don't high technology to do that. Yes, right.
Thank you. So is there any other question? But for me, I also concerned about the impurity, like such as in the previous talk by Professor Yang that he mentioned about fluorine. So is there any process that we have to deal with the fluorine in your case or?
That's right. I already take note on what he mentioned about Professor Yang. Two things that I may have the question further to Professor Yang is how can they separate nickel and copper from each other if we don't use electrolysis? And one is that fluorine contaminate might be one is the cause that we have to concern. That's very good presentation as well. I could not answer your question this moment.
Any other question from the floor? Okay, so if not, let's thank Professor Nurak again. Thank you so much.